Hi, this is Tom Reardon, math teacher from Ohio. I want to show you how I use TI-Nspire activities for the mathematics classroom. Today we're going to look at an activity called Circle Area Circumference. This is an activity that you can use on the TI-Nspire CX handheld, and I'll tell you where you can find over 1,000 free activities at TI-Nspire.com. This could be used in either a geometry or an Algebra 1 or Algebra 2 class depending upon your students. And let's get right to the activity itself. Here I'm using the TI Smart View emulator that comes part of the TI-Nspire software. And I'm going to be emulating it on an interactive whiteboard. Each student would be doing this activity on his or her own individual handheld, and what's good about that, at his or her own pace. So moving to the next page. It gives you the directions, and I should tell you that along with these activities they'll be coming the student worksheet, the teacher notes, and solutions. So it all comes in a package. So I'll give you these directions as we're going along. All right, you'll notice on the screen here we have a table, we have a picture of a circle, and we have a graph. And the directions on the worksheet would be to grab the endpoint of the radius and pull it out back and forth and watch what happens. So I'm going to do that with my finger. The students would be doing this with a mouse on their handheld. So I'll grab this point here, pull it out, and you can see the circle's getting larger, smaller, there. Now a lot was happening while I was doing that, and that's the power of TI-Nspire, is this automatic data collection. I was automatically capturing the length of the radius, the circumference, and placing it into the table. And if I can put it into the table or to the lists, I can automatically plot that as well. So the purpose of the activity is to see if the students can take data that they understand, radius and circumference, and see if they can model it mathematically. Now for this one here, one of the options I would like them to do is kind of plot a line and use one of the features of Nspire, and that is to move the line or rotate the line. So here's what I'm going to do. Right now I wanted those three pictures to be together so they could see the power of how these things were changing and see how one affected the other. I'm going to now put those into three separate pages. So there's the table of values or the lists. There's the geometry, and here's the graph on a much nicer screen. And the students can do this on their handhelds as well. I want to bring up a function input line. I'll press the tab key. And I'm thinking it's linear, and it looks like it kind of might go through the origin. So I'm going to go with just f of x equals x. And you can see I was pretty far off. But now what I'd like the students to do is, again, use one of the features of Nspire, and that is to grab the line and rotate it. And as I do that, the equation will change to illustrate that. I'm also going to move this equation up here so you could see it better. There's the graph of f of x equals x. Again, the students could be doing this with their mouse. Click on this, grab this line, and rotate it, and try to get it to match the data. Kind of a movable line type deal. All right, so about 6.21. F of x equals 6.21x, which seems like it's pretty close. And it's this point that I'd ask the students, can you come up with an exact equation of this line to model that data? And a lot of students say, well, I think mine's better. And I usually will get a student or two per class that'll say, I think I know exactly what that equation's going to be. Since this is the radius versus or circumference, versus the radius, then this should be actually the formula for the circumference of a circle, which is 2 pi r. And in this case, that equation would be 2 pi x, because x is representing the radius. So I'm going to go back to this equation, and I can go ahead and change it there right on the screen and type in 2 and then the pi key, x, and press enter. And some students will say, well, I don't think that's any better than mine or any worse than somebody else's. So I'd like to go back and show them how it is exactly that. So I'm going to go back to the list and spreadsheet. And in the third column, in the diamond row, I can type in that function f1, only evaluate it at each one of these radius values. And watch what happens. f1 of, and since I'm kind of lazy and don't want to type the word radius, I'm going to go to the variable key and say, that's exactly the one I want, that radius right there. And when I press enter, I want you to compare these two columns right here. And you can see it's not close, it is exact. That is exactly the equation that models this data, and it should. And this is kind of a powerful happening in this problem, because the students can now see the relationship between a linear equation and a formula that they learned maybe back in middle school. Now that would be great if that's all this did, but I go on to the next part, and now instead of talking about circumference, we're now going to talk about area. And I'm going to do the same thing again. Go over here, the student is asked to grab the endpoint of the radius and pull it out, pull it back in, and you can see the data is being plotted again, only this time it's not linear, nor should it be. And students will say, oh, it looks kind of quadratic. And again, we're going to do the same thing. Try to model this by guess and check. So I'll do that Control-6, which again explodes this out. And I'll move along to the graph. And this time students will say, well, I'm going to guess x squared. So I'll tab and go with x squared. And you can see that it's kind of curvy. It is quadratic, but it's not close enough. So again, with their mouse, they can grab, I'm going to move this up so you can see it, grab this curve, pull it up, and try to model that as closely as possible. And I'll go about with 3.11 x squared. And it's at this case that a lot of students will say, wait a minute, the area formula for a circle is pi r squared. That should be exactly pi x squared. So let me go back and edit that. And that would be a perfect match. And normally I would go back and show you that it's a perfect match like I did with circumference, but I think you get the idea. So where can we get activities like this for free? Website TI-Nspire.com. Not only do you get the TI-Nspire or TNS files as they're abbreviated, you get student worksheets and the teacher notes and solutions, all there for free. You'll notice at this website you have activities for all levels: middle school, grades math, Algebra 1, geometry, Algebra 2, pre-calculus, calculus, statistics, all there. And each one, if I would click on, let's say, Algebra 2, has several units below it, and each unit, like if I would click on, let's say, polynomials, has several different activities there. And you'll notice that the activities are listed, and if you find one that you kind of like, you click on it and say, I'd like to know more about polynomials, factors, roots, and zeros. So you click on that, and it should take you to a page that shows you a silent video of it, page by page, so you can quickly assess whether or not this is what you want. It has the objectives, it has the vocabulary, it tells you about the lesson, it tells you related lessons, and to the right, it tells you how you can download either the activity or the TNS file or the student worksheet or the teacher worksheet. My favorite, download all the files as one zip, quick, easy, efficient. How it aligns with the standards, textbook alignments, and also how it aligns with the Common Core state standards. All that is there. So to summarize, this activity we just did ties together concepts in both geometry and algebra. And the dynamic data collection is impressive, but the connections to the formulas that we do by mathematical modeling is just excellent, truly excellent. So just to show you the difference here, how I use color, also how I use shading. For the circumference, it's the outline. For area, it's shaded pink in the color coordination there, both on the graphs and in the tables. Thanks for watching the video today. We hope you enjoyed it.